Alright, so for this Prezi, I'm going to try to draw on top of it. We'll see how this goes. So for quarter two, we are talking about probability for the most part. So you are going to need to have out notes because you're going to need to take some along with this video, because there are going to be some important notations and problems that we're going to go through. So the first thing that we need to know is that P of E, which is this P in parentheses with the E, is the probability of an event. So it doesn't have to be the letter E. You might see P of A, P of B, P of C, anything, but it's the probability of whatever we're talking about occurring. Next, we're going to talk about the complement. So the complement of anything is whatever it's not. So for the complement of event E, it is the set of all outcomes in a sample space that is not included in the event. And we call this P of E with the little apostrophe, that's called E prime. So this is the probability of E prime. That's the complement, everything that's not occurring. So when we look at the probability of an event plus the probability of all the other stuff that's not occurring, that should equal up, the two percentages should equal to 1 or 100%, right? You could do the same thing, which most of us in statistics, we actually use this formula at the bottom, which is going to be that it'll be easier for us to take whatever is not occurring and then subtract it from 1 to find out what is actually occurring. So next, okay. So use the complement when solving problems that discuss anything that's not the event. So for example, find the probability of randomly choosing an employee who is not between 25 and 34 years old. So sometimes it's easier to find out, okay, that small amount of who is 25 to 34, finding out whatever that probability is, and then subtracting it from 100, and that's all the people who aren't 25 to 34. Now I'm going to try to remove this giant box that I now have, but I'm not sure how I can do that. You're probably thinking just erase it, but it's not that easy. Oh. Okay, so now we're going to talk about conditional probability. So you're going to want to write this down. So conditional probability is, it's very fickle. It is the probability of an event occurring given that another event has already occurred. So conditional probability of event B occurring given that event A has already occurred is denoted as the probability of B given A. So that's how you write it, and that's how you say it. And you have to write it like that on your exam. So for example, if 2 cards are selected in sequence from a standard deck, find the probability that the second card is a queen, given that the first card is a king. So first we have to think about, all right, so how many kings are there in a deck? So there are 4 kings in a deck, and there are 52 cards. So does getting a king affect getting a queen? It doesn't actually affect getting a queen because I'll still have 4 queens in the deck. But it does affect how many cards there are because it says the first card is not replaced. So if I pull a card out, whether it's a king, an ace, a jack, as long as it's not also a queen, I now, when I pull out a queen, I don't have 52 cards in the deck. I actually have 51 cards in the deck. So my denominator would be 51 here. But still, the second card, we still have 4 queens. So the probability of getting a queen would be 4 out of 51 if the first card pulled out is a king. Okay. So now it says, two events are independent if the occurrence of one event does not affect the probability of the occurrence of another. Two events A and B are independent if the probability of B given A equals the probability of B, or if the probability of A given B equals the probability of A. So this can be kind of confusing, but this is the only way for you to know if there's independence. Meaning, are they dependent or independent? Do they have an effect on each other or do they not? And this is really important because eventually it's going to get difficult to figure it out without doing some math. So let's just think about, I think I have some examples coming up. If I can get it to play. We already wrote that down. All right, so selecting a king, not replacing it, then selecting a queen. So are those two things independent? Do they have an effect on each other? So selecting a king out of a deck, that probability would be 4 out of 52. And then not replacing it, and then selecting a queen, so that would be the B given A, right, is selecting a queen, and that we already know is 4 out of 51. If these two things are equal, then they're independent. So are these two things equal? No. So they are not independent. Tossing a coin, and why they're dependent is because of this bottom piece, more importantly. So if I take a card out and I don't replace it, obviously that's going to affect my probability in the deck. Tossing a coin and getting a head, and then rolling a die and getting a 6. Right there, do those things have anything to do with each other? No, they don't. So those two things would be independent. So moving along, if it would let me. Why? All right. So now if we look at a particular knee surgery is successful at 85%. So if we find the probability that 3 knee surgeries are successful, that none of the 3 knee surgeries are successful, finding the probability that at least one of the knee surgeries is successful. So finding that things are successful in a row, we would use the multiplication rule. We would multiply, because I would be saying the key rule here is the word and. So if I have 1 knee surgery successful and another, then we're multiplying. So I would take the 85% times 85% times 85%, and that would give me my answer. But I literally gave all my calculators out, so I don't have a calculator right now to figure out what that actual number would be, but that's how you find it. So find the probability that none of the 3 knee surgeries are successful. Then that would mean that we would do the opposite. So if none of them are successful, then I would have all of the other portions. So first I would take the percent that's not successful out of 100. So 100 minus 85 would give us 15. So 15, if 15%, and there's 3 of them, so 0.15 times 0.15 times 0.15, that will give you the percent that's none of the 3 are successful. Then find the probability that at least 1 is successful. At least 1. So meaning it could be 1 or it could be more than that, right? So basically, I want everything except for the first one Or no, I could have the first one, right? Because I could have all three happening. But at least one means that I don't want none of them to occur. So I would just take 100% minus whatever we got for this number here. And that would give you the number of at least one successful knee surgery. So trust me, when you find out those numbers, you're not going to want to have knee surgery, like, ever. All right, moving right along. Aw, man. All right, so what I want you to do next is to go on to Schoology and try the homework problems that are on there, and they are on a Word document. So just follow this video and it should help you. I'm also going to post some other videos from Khan Academy that should also be helpful with these topics.